A module diagnosis without taking anything apart will save you time and money. With our CAN bus multiplex trainer, it's possible, and today we're going to show you how to do it. Let's get started. Once our trainer and scanner are connected, we search for the vehicle's VIN. When we find it, we can access the modules. The first module we're going to diagnose is the engine control module, specifically the oil pressure sensor. We can see in bits 5 and 6 the values corresponding to 0, 61 volts, and we confirm it on the scanner. For this type of sensor, a value close to 0.5 volts indicates low pressure, which is completely normal because our engine is off. If we start the vehicle and accelerate, as we can see, the value changes in our software in bits 5 and 6. We can also see it graphically on the scanner, confirming that this sensor is in perfect condition. Now, let's move on to the MAP sensor. And here, we find the first fault. We see that in bits 5 and 6, we have the response 0x00, and the signal is 0 volts. This value is not normal, because a MAP sensor always operates between 0.5 and 4.5 volts. When the signal is 0, we immediately know there's an electrical problem. Now we diagnose the MAF sensor. As we can see, it varies normally in bits 5 and 6. With the vehicle warmed up and idling, it's giving us between 15 and 25 pounds per hour. If we accelerate, the value should rise quickly, which indicates the sensor is correctly measuring the airflow, in this case reaching up to 35 pounds per hour. The MAF sensor is in perfect condition. This is the AFR sensor, the air-fuel ratio sensor. We can see a slight change in bit 6 because this sensor works with very small currents, not voltages. We see a value around -0.0.14, which indicates the mixture is slightly lean. In this case, we accelerate and the value does not change, suggesting a possible fault in the sensor. Even though the reading itself is correct, it should vary under acceleration, so this is ready for a deeper interpretation. Now I'm going to show you how to simulate a fault in the two sensors that were working correctly. We go into Go Training in our software and fill the data field with the MAF sensor's response. We set it to 100 milliseconds, enable the 7E8 ID box, and activate bit 6. We press send, then start. With our potentiometer, we simulate a drastic increase in the mixture, reaching values like 5,000, 193 pounds per hour, which is impossible in a real vehicle, so we interpret this as a total failure of the sensor. In the same way, with the oil pressure sensor, we follow the exact same process and increase the value using the potentiometer. We reach 199 volts, which is also an impossible value for a real vehicle, meaning the sensor is clearly faulty. This way, we can diagnose and even simulate faults, so you can see exactly how a vehicle reacts. Don't forget to follow us for more tutorials.